All right, so our goal today is to understand our fourth and final transformation, which is how to create dilation transformations. In other words, how to shrink or enlarge objects. Okay, so what we're basically trying to achieve here, and the reason why it's been separated from the other transformations, is that this is the only transformation where the shape we end up with, let's say this was the original and it was blown up to make this shape here, is that it's not congruent. All the other transformations we did, reflections, rotations, translations, you always ended up with the same exact congruent shape. But here, we don't end up with a congruent shape, we end up with a similar shape. And so this is why we separated out the last transformation, dilations, until now, because now that we've talked about similar shapes, we have a little bit better understanding. Now, first thing you'll want to know is, well, how can you tell whether two shapes are actually similar, or they just look similar? Okay, well, one way to tell is that, of course, the angles should be the same. The corresponding angle should be the exact same angle. And then, just like with scale factors and what we've talked about with similar shapes, that these shapes should all have the same ratio. Now, another way to do that visually is to actually find what's called the point of dilation. In other words, there should be a point, well, let me just show it to you. If I take this corner here and I draw a line and match it up to the corresponding corner, but then I extend it to a certain amount. And then I do that with the other corners. Let's take this top vertex here, the top vertex here, but then continue it, and making sure I'm lining up right here, like so. And then I do it with the third and final vertex to here, that they should all match up in the same location, which is right here. This is what we call the center of dilation. All right, because it's the one place, I like to think of it as a flashlight. If this flashlight were beaming outward, it would hit this object, and then this is the shadow that it's casting. And so this is a way to physically tell whether or not two shapes are actual dilations of each other by matching up the corresponding vertices and to find that one spot where all three lines meet up. All right. Now, we're going to also look at dilations mathematically. So to dilate a figure with respect to the origin, meaning that the origin is always going to play the role of that flashlight I was talking about. So if this was an example we actually did, this would be the origin, 0, 0. What you do is you multiply the coordinates of each vertex by the scale factor of k. In other words, what we're going to do in the next couple examples is we're going to take a shape that's already on graph paper. So each of the vertices is on some coordinate. To get the dilated version of that, you just take each of your coordinates and multiply it by some scale factor k. So if it was 3 times as big, k would be 3. If it was half as big, k would be 1/2. And that leads us down to this small note here, but it's an important one, is when that scale factor is bigger than 1, it's going to be an enlargement. So if it's 1.227, 200, you know it's going to be enlargement because the scale factor is larger than 1. But then anytime that scale factor is somewhere between 0 and 1, some fraction, then it's going to be a reduction. 1/2, 1/4, 2/3. It's going to make the object smaller.